In Activity 10, Making a Bulb, students construct their own light bulb to test their ideas about how a bulb works. They make an incandescent light bulb and describe why the filament of a bulb glows when the circuit is closed. Finally, students compare their bulbs to common household bulbs. You will need the following materials from the kit: Activity Sheet 10, Parts A and B, D-cell batteries, battery holders, electrical clips, Fondstock clips, 15 cm insulated copper wire pieces, 15 cm number 32 Nichrome wire, 7 cm by 7 cm reclosable plastic bags, and modeling clay. You will also need to provide metric rulers and a knife. To prepare for the activity, make a copy of Activity Sheet 10 Parts A and B for each student. Divide the block of modeling clay into 16 equal-sized blocks. Each team of 2 will need 3 batteries, 3 battery holders, 6 electrical clips, 6 pieces of copper wire, a piece of clay, 2 Fondstock clips, a metric ruler, and a piece of number 32 Nichrome wire. To begin the activity, lead a discussion by asking, how many different types of light bulbs can you name? Answers may include bulbs found in various lights at home and at school, street lights, headlights on cars and trucks, and so on. Review with students what they learned about bulbs the previous activity. They should remember that the case is connected to a support wire, and the support wire is connected to one end of the filament. The other end of the filament is connected to the other support wire, which is connected to the tip on the bottom of the bulb's base. Explain to the class that the bulbs they have examined are incandescent bulbs, which produce light as a result of electric current being forced through a high-resistance filament. If there is an illuminated fluorescent bulb in your classroom, this is a good time to bring students' attention to it. Help students understand that fluorescent bulbs also use electric current to make light, but instead of filaments, they have a special material coating the inside of the tube that glows when electric current enters the tube. Borrow materials from one team and invite suggestions for how to construct a bulb. Then, construct the circuit as shown in Figure 10.1. Remind students that the filaments may become very hot and that they should never touch glowing wires. The proper way to remove a Nichrome wire from a circuit is to first disconnect the insulated copper wire and then allow the Nichrome wire to cool. Next, distribute a copy of Activity Sheet 10, Parts A and B, to each student and the materials to each team. Instruct students to construct their setups and run their experiments, following the instructions on Activity Sheet 10, Part A. Results will vary with the strength of the batteries. For instance, weak batteries may hardly cause the filament to glow, and fresh batteries may burn out the filament. Ask students what happened when the circuit was closed. Students should have observed that the Nichrome wire glowed. Then ask, why do you think the Nichrome wire glowed? Help students understand that a lot of electric current was being pushed through it, and that the Nichrome wire is a high-resistance wire. Encourage students to think about the difference between their constructed bulbs and common household incandescent bulbs. They should notice the constructed bulbs are not as bright as a common household incandescent bulb. Ask students, how could you increase the brightness of your bulb? Students may suggest forcing more current through the filament by adding more batteries. Help students understand that adding batteries could cause the filaments to burn out. Then, challenge students to think about other ways their light bulb is different from the common household bulb. Students should point out that the filament in a household bulb is housed in a glass shell. Explain that if oxygen were to touch a very hot wire, it would cause the wire to burn and break. The glass shell keeps the oxygen in the air from touching the filament. Let students know that the filament in a household bulb is made of tungsten, the same metal used in the bulbs examined in Activity 9. Remind students that tungsten can resist very high temperatures. Finally, let students know that in the next activity, Making a Fuse, they will construct and observe circuit fuses. To conclude the activity, have students return all batteries, battery holders, electrical clips, Fondstock clips, and wires to the kit. Place each piece of clay in a plastic resealable bag so it can be used again in Activity 11. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.